Hello everybody, welcome into another lesson. So today we are going to begin the coordinate geometry unit, and we are going to kick that off with the distance formula. Now some of this may seem like a review from algebra for a very good reason, because coordinate geometry in general is very algebra intensive. If we have any two ordered pairs in the coordinate plane with arbitrary coordinates x1, y1, and then x2, y2, you can find the distance between those 2 points in the coordinate plane by applying the distance formula. The distance formula is the square root of the whole expression here of the second x coordinate minus the first x coordinate raised to the second power plus the second y coordinate minus the first y coordinate raised to the second power, the square root of the whole thing. So that is how you find the distance between two ordered pairs. Now we're going to do a few exercises here to demonstrate this. So we're going to find the distance. We're going to just do 4 exercises. Let's say you were given the points -6, -2, and -7, -5. Alright, so yes, let's say you got those two ordered pairs in the coordinate plane, -6, -2, and then -7, -5. How would we find the distance between those? Well, apply your distance formula. So you start with the square root symbol. So your second x coordinate is -7 minus your first x coordinate of -6. So you'd have -7 minus -6 raised to the second power. Plus, now you're going to do your y coordinates. You'll take your second y coordinate of -5 minus your first y coordinate of -2, so that'd be -5 minus -2 to the second power, which will simplify this a little bit. -7 minus -6 is -7 plus 6. That'd be raised to the second power. Plus then you have -5 minus -2 turns into -5 plus 2 to the second power, which will simplify this a little bit further. Now -7 plus 6, that's -1. That'd be raised to the second power. Plus, then you have -5 plus 2, that'd be -3 to the second power. Which now we just deal with the exponents. -1 to the second power is +1, plus that -3 to the second power, that's +9, which would give you a distance of the square root of 10. And we know the square root of 10 doesn't simplify any further, so, and we're just going to leave it in the radical form. So the distance between these 2 points would be the square root of 10 units. If you really want to get a decimal approximation, feel free, but that's really not necessary. In fact, in future lessons, it may be helpful to leave it in radical form, because you can apply the distance formula to find the lengths and areas of rectangles and triangles, you know, stuff like that. So that's just something to keep in mind. Okay. Let's find the distance between the points 3, 2, and then 5, -2. So we're given the two ordered pairs 3, 2, and 5, -2. Well, let's find the distance between those points. So of course, start with your square root symbol. You'll take your second x coordinate of 5 minus your first x coordinate of 3, raise all that to the second power. Plus now you'll take your second y coordinate of -2 minus your first y coordinate of 2, raise that to the second power. which then we can simplify this. 5 minus 3 is positive 2 to the second power, plus then we have negative 2 minus 2, which would turn into negative 4 to the second power, which will simplify further by dealing with the exponents. 2 to the second power is positive 4, plus negative 4 to the second power is positive 16, which gives you the square root of 20, which we want to put the square root of 20 in simplest form. That can break down into the square root of 4 times the square root of 5. So you end up getting a distance for between the 2 points of 2 times the square root of 5 units. So the distance between those two ordered pairs would be 2 times the square root of 5 units. And I got 2 more exercises, then we're done with this lesson. The distance formula is actually pretty straightforward. So, what about we have the points negative 8, 6, and then we also have 0, 0, otherwise known as the origin, 0, 0. We want to find the distance between the points negative 8, 6 and 0, 0, otherwise known as the origin. Well, let's apply the distance formula. Of course, start with your square root symbol. Take your second x-coordinate of 0 minus your first x-coordinate of negative 8. So that'd be 0 minus negative 8 raised to the second power. Plus then you would have your second y-coordinate of 0 minus your first y-coordinate of 6 raised to the second power, which would then, we'll simplify this in the parentheses. 0 minus negative 8 turns into 0 plus 8 to the second power. Then you'll still have plus 0 minus 6 to the second power, which then will simplify further. 0 plus 8 is obviously 8 to the second power here. Plus 0 minus 6, that'd be plus negative 6 raised to the second power, which we know 8 to the second power is 64, plus negative 6 to the second power is positive 36. Well, 64 plus 36, that's 100. You have the square root of 100, which would give you a distance of exactly 10 units between negative 8, 6 and the origin. So you have a distance of 10 units between these 2 points. And I got one more exercise for this lesson, then we're done. Alright, what points do they come up with here? We got the points 12, negative 1, and then 0, negative 6. So we have to find the distance between the points 12, negative 1 and 0, negative 6. So once again, we'll apply the distance formula here. So go ahead, take that, you'll get the square root. Then you'll take your second x-coordinate of 0 minus your first x-coordinate of 12, raise that to the second power, plus now you'll take your second y-coordinate of negative 6 minus your first y-coordinate of negative 1. So you'd have negative 6 minus negative 1 raised to the second power. So you'll still have 0 minus 12 to the second power, plus, now let's do negative 6 minus negative 1. That actually turns into negative 6 plus 1 raised to the second power, which we simplify further in the parentheses. You would end up getting 0 minus 12 is negative 12 to the second power, plus then you have negative 6 plus 1, that would become negative 5 to the second power, which we simplify further with the exponents. Negative 12 to the second power is positive 144, plus then you have negative 5 raised to the second power, that's positive 25. So the square root of 144 plus 25 would turn into the square root of 169, which would give you exactly 13. So the distance between 12 negative 1 and 0 negative 6 is exactly 13 units. So that's it for the distance formula in general. The next lesson we're going to apply the distance formula to testing if points are collinear. That's also a very useful thing to know. So I hope everyone has a great day. Take care.